Well, I think it's just because it's sort of algorithmic. You know, there's cute formulas for doing things, and you can just put it in a handout. So kind of the impression I got from my undergraduate class was that error analysis was sort of the key to this whole scientific reasoning. You know, how do you do an experiment? Good error analysis. But I don't really think that's the case. So the timeline for the project, right now we're actually ordering some new equipment, some new computers and oscilloscopes, and maybe some other electronics, just so the students have like better equipment to work with, because that has been somewhat of a limitation. And then the thing we're also doing right now is we want to prepare assessments, or just some way to observe what happens in this pre-reform course. And so that's what I want to talk about for the little bit of time left. And some of it I'll probably just bug you guys like after the meeting, just to get your opinions. But we want to be able to say something useful about the pre-reform course, but we haven't actually established learning goals yet. And I mean, we are going to establish learning goals, and that's what we're going to do next semester, and get a lot of faculty input from industry and various people, and from students. But we just need to be able to actually like see the class happening live and you know, evaluate it. So that'll be sort of the best we can do for a control group in the experiment. So I guess the questions I have, you know, what would be a good thing to learn about observing this course? What like observation protocols should we use, or have other people used for lab courses, or even non-lab courses? Since I'm very new to all this, you know, are there any like ready-to-go assessment surveys, concept inventories that would be relevant, or that we could just adapt for our use? Like what technology? Like, I mean, is it actually worth videotaping anything? Is that just so much work that you know, I would just sit all day watching videos and not learn anything? I mean, you know, these are just questions I have, and that I know there's a lot of experience here, and I just wanted to draw on that. You know, there were just a lot of different things I could imagine we wanted to learn. I mean, I guess we talked about some of the attitude stuff, like even like, you know, why do undergrads not take the class? You know, what do students think about when they took the class? One thing that Chuck, who's teaching it next semester, has identified is kind of a key attitude thing. It's just like students are kind of afraid to work with some of the complicated instruments, just because they think they might break it or get hurt or whatever. I don't know. But you know, it just inhibits their ability to do good science. So trying to like, you know, evaluate that. How does that process work? You know, just like another kind of objective of the lab course, which I think will remain even though we don't have official learning goals, is just lab skills. Like, how effective are they using a multimeter or an oscilloscope or something? You know, is there any like easy way to measure that? Scientific reasoning. You know, at least when are they spending time doing sense-making stuff during the course? Is there any way we can actually assess like before and after the course, like just general scientific reasoning things? I don't know. Even did they learn error analysis better during the course? I think there's some communication stuff that we could look at, just like how do they work as a group, or how do they interact with between professor and students. And then there's a lot of different conceptual issues. You know, I mean, like the theoretical background to a lot of the topics is just, you know, some of it's just complicated, and sometimes they're. So, from talking like recently to Chuck and Heather and Kevin Stenson, I guess Chuck and Kevin taught it last year, but there's an NMR lab that, you know, apparently this really confuses the students. Like, they just don't understand what's going on. And so are they actually making some connection between the physics and this sort of black box that they work with? Other things that, you know, to look at, you know, are just gender differences, or I mean, there could be a lot of things in there. So, you know, if you guys like have any questions that you've always wondered about in a lab class that we can throw in here, or just better ways that you can pose these questions, or do you think I posed them all wrong and there'd be a better way to phrase them all? I'm open to any kind of criticism. Or
Ben, question: How does assessment work now in that course? Like, what is being looked at to decide if students get an A or a B or a C in that?
Basically lab reports. That's the primary.
But what about the lab reports? Is it just sort of a
Depends
gestalt?
on the instructor.
Yeah.
Some have a very strict sort of rubric. Other people are, well, that's kind of an APT. It really depends on the instructor.
Yeah, so is the lab report like 60% of the grade? I was trying to look at the...
Lab report, it's most of it. There is a final project that includes an oral presentation and a final lab report. But lab reports consist of at least 80% of the grade.
Do they do the lab report every week, regardless of whether they completed
No,
something?
just one per experiment.
Per experiment, yeah. Okay. So, yeah. So like one example of an observation protocol, Carolina and Etkina, that was a paper I cited earlier. They use this like method where they just kind of watch the students interacting in their group, and in sort of real time they would make note of what kind of activity is this. Is this a sense making, writing, procedural, TA help, off task? They had these categories, and then they had subcategories within those categories. And in real time, they would just, the student doing the research would just, just watch the student, watch the lab class happening, and seeing, then they made these fancy diagrams of how the students divided their time, and they could compare, like, how does a student spend their time in non-design lab versus a design lab? How much is the total time? What is the time spent, like, asking TAs versus sense making? Those kind of activities. So it seems like that's definitely one interesting approach I've seen. I mean, I did have some questions about observation. Like, I definitely want to read up a lot more about what was done for the non-lab classes here. Just whether it's E&M or quantum or mechanics. What are you guys actually doing when you just kind of seeing how the students are learning on a day-to-day basis. So I think there's definitely, I'm sure I can adapt a lot of that stuff. Regarding to the PhET stuff, one thing I was really curious, it seems like there's a lot of analogies between the way a student interacts with a simulation and the way a student interacts with an actual experimental system. They're both kind of black boxes. One you can break, one you can't. Just when do they just try things? Do they just try things? I didn't know if PhET had ways to assess how interactive or engaged students were with stuff, or just I don't know. However that's done, I was wondering if we could do something, at least in regards to how students just interact with, say, an oscilloscope or a lock-in amplifier or something. I guess I've heard some of Valerie's stuff on physics and everyday thinking, and I was wondering. I know you guys videotaped a lot of lab activity stuff, and I was wondering how you processed through that, how you filtered it. Maybe we can talk about it some other time, but it was on my...
I always recommend videotaping, but you gotta be prepared to analyze that stuff.
Yeah.
But I think that if you do have that level of interaction within the classroom, you want to understand how the students are interacting with the material, then you need to videotape.
Yeah.
Yeah, I would agree with Valerie that I think for a kind of to get that videotape of them doing, the labs this spring and contrast that with whatever you end up creating. Field notes aren't going to capture the details that you want to be able to report.
Yeah.
Although you could, I agree. I think you want to videotape selectively along the way, because you can spend all of your time doing that, as Karen and Ben know, I think, and end up with boxes of videotapes. Not that that's bad, better have too much than not enough. But targeted field notes will allow you to create those graphs like the Rutgers group.
Yeah, and so
I think that's a great measure. Rutgers group also has rubrics for evaluating lab write-ups.
Yeah.
So you ought to do scoops in this as well, is to take collections of student work that demonstrate how it is that students are thinking about things.
Yeah. Basically anything they sort of produce written or presentation, I thought we should gather.
Right. I guess with the videotape, it's you're not sure everything that's going to change. You don't know what rubrics you're going to need to use right now.
Yeah, that's true.
So,
yeah.
I agree. Taking good field notes is useful too, because then you get broader pictures. But taking at least getting a couple groups working on their labs and videoing their conversations so that you want to, if you do see major differences in what they're discussing and how they're interacting with the equipment and the questions they're asking, then you can code that up. And you don't have to code up every videotape.
Yeah. Okay, that's some good feedback. Yeah, and just any other options, people have to would be any other options would be appreciated.
One,
Yeah.
and I don't know how you're gonna, do pre-post assessments around this, but when thinking about what we do with FED, in testing FED and how students are interacting with the simulations, we do a lot of individual interviews. So, you have to think about how many was enough to make a general claim, but you could do kind of pre-post assessments around how students interact with equipment they haven't seen before. By doing kind of individual interviews.
Yeah. Okay. Yeah, I'll definitely talk to you more about that. You're getting
Some idea.
citation. Yeah. Yeah, no, that sounds good to me. So, in addition to the videotaping, more kind of open-ended kind of observational stuff, I guess the question, are there any sort of kind of prepackaged assessments that would be useful? Just from looking online, it seems like a lot of stuff is in terms of attitudes or scientific reasoning stuff. It's more geared to intro, beginning science level courses, some just general science, some intro physics. Is that still relevant, even to an advanced class? I mean, would it be interesting at all to see how, junior, senior level students do on these and then do after the course? I mean, maybe it's too simple, I don't know. Is it legitimate to sort of adapt this kind of model, or these kind of questions, and just make it a little bit more relevant to the advanced lab setting? Or is it kind of with an interview, just ask more open-ended questions and just get feedback? Or I don't know. Yeah.
It seems like I know your slide, your 4 slides back. You don't have to. It was something you wanted to measure what was the class now, and then determine the learning goals for what you want the class to be like.
Yeah.
It might make your life easier to decide what you want the goals to be, since there are so many. There's infinite ways you can evaluate a course, and the outcome measure you choose has a huge impact on the effect that you see. And so since there are so many options, it might make it easier if you decide the goal, then come up with, maybe the goal is a specific type of student-to-student interaction, or maybe the goal is content outcome measure, whatever it is, and then you can sort of go back and look at the course now, and then sort of design the new course, and then you could really test, first we want to do no harm, so first we want to see, is there something that's wrong here, that you have some sort of evidence that you want it to be different, but to first sort of look at it and test it, given these new goals, might be easier?
Yeah.
In terms of deciding the different
It would absolutely
outcomes.
be easier. It's unfortunately the time scale. We basically really don't have learning goals. The course is starting in 2 months. So we were hopefully just to kind of throw at and gather as much information as possible so that when we do come up, we can sort of go back with that information and assess something. It's definitely backwards, but I don't know how else to do it.